Elias, we can start. Ray, we can start.
Ready? Can you see us? Okay. Welcome, everyone. Great to see everyone here and welcome you with us in this very interesting webinar. So just to give you a very quick overview, this started as part of the course that we finished a couple of weeks ago, Data Science for SEO, which we did in Python. And we had a few discussions with some friends in a few companies, and they agreed for some very, very generous gifts for the students. And so we had 4 companies: WordLift, DemandSphere, Keyword Insights, and Windsor AI. And today, Ray and Andrea took further steps in this support, and they prepared some notebooks for us, code to actually see how you can use their APIs and not just get the credits and get lost somewhere. So we thought this would be interesting for anyone. And we decided to open it up to anyone. And so here we are. So today we're going to have 2 overviews of these workflows, and we'll take a quick look at the notebooks and the code, and then we're all available, obviously, to answer any questions and discuss further what you can do with them and how you can do this. So I'm not going to go any longer, and we can. I'm sure you can't wait to start. So we start with Andrea to give us the overview, the notebooks, and please go ahead.
Yeah, thanks, Elias. Thanks, Ray. I think it's been quite exciting to get to the point of preparing these. We've been really working until the last minute. And today we are gonna do a knowledge graph. We're gonna build a knowledge graph from an e-commerce demo website. And we will start from crawling the website using advert tools. Hi, Steve. Hi, everyone. And we build a knowledge graph because we want to exploit the data and do something fun with it. So the plan of the day, it's really to combine different tools to build these long-term memory, right? So I call a knowledge graph a long-term memory. It's actually a highly dense repository of facts, a knowledge graph. It's a graph database that contains triples that describe things. So we are going to scrape a website, extract some of the product attributes of an fictitious e-commerce website, build the graph, but then the fun part will be to use the embeddings. So create a representation of these products into a low-dimensional space that we will use for building a small recommender of similar products. So we get the graph, then we build embeddings, then we start using the embeddings for creating semantic search, product recommendation. But then we also use the graph for building a chatbot, an AI assistant. So this is to demonstrate the different use cases that arise from building this knowledge graph. And yes, of course, you can stop me, ask questions, or we can review, them afterwards together. And today's a special day because it's the first day that we introduce the WordLift client. So a Python library for you to interact with WordLift platform using Python. And so I really want to do this with Ray and Elias because, of course, and with you guys that have been going through a Python course, so that we could actually geek out, together. So we have actually here 3 tools. RDF-lib. It will allow us to create triples for the products and for the category pages. It's going to be very elementary as markup and as a graph structure, but enough for us to interact with this data. And then, of course, we have the beloved advert tools for crawling the site. So here I have imported, the different libraries that we use. The first step is really to set the scene and crawl the website. So we define a few parameters for, the spider. We're just gonna, get 10 pages out of these demo e-commerce website that we have. And we're extracting, a few bits from the pages, the product description, the price, the category that the products belong to. And then we're gonna differentiate the product, the product pages from the listing pages just by looking at the structure of the URL. So very plain and simple. Then we're gonna extract page data. So we're gonna create a collection of data points that we can use for building the graph for the product pages and the listing pages, okay? So it's very basic. We're using the data coming out of the crawler, and then we are building a data frame in pandas with some attributes that we will use for building the graph. So let's review now the code for building the knowledge graph. So one thing that we want to do is to define, of course, the WordLift key. And this is something that you can see in the dashboard. So when you enter into mywordlift.io, you have this API key over here, and then you have the knowledge graph ID, the base URL over here. So this is what you want to use for configuring, your knowledge graph. So here you can, make sure that you use your own key rather than, I'm taking the key from here, but of course you can add your own key directly into the notebook. So the way in which we're going to build these, it's really by creating entities out of product and entities out of category pages. Okay, and this is the code that we are going to use for doing these. And there is a small interesting details over here. So when I am creating the product page, and here we see the product entity, so I'm getting the data from the crawl, and now for each row in the data set, now I am building the schema for the product. But when doing so, I'm also triggering, these meta request embeddings. Now, this is all it takes for WordLift to build embeddings out of the fields name and description. So we are instructing WordLift to create a knowledge graph, but also to create embeddings. Now, embeddings are a representation of the content that we will use for semantic similarity. I'm not going to get deep into embeddings. I hope that you are somehow familiar with the concept of semantic similarity. Otherwise, of course, we can review it together as we progress. Here, I'm going to clean up the knowledge graph when I start in the beginning. So we restart from scratch. One important thing when we build a knowledge graph is that we create entities, and every entity has a unique identifier. Okay, we want to be able to call entity data using this unique identifier. So here I'm doing this simple replacement of URL because the website that I'm using, which is this demo e-commerce website that we have, has already its own knowledge graph. So in order for me to create another knowledge graph, I created a fictitious URL that we're going to use in the creation of the entity. So here I'm not doing anything else than just creating, the product entity and the entity for the collection page with the data that we got from the crawler. And here I kind of keep it explicit so that you could see that, we're sending to the graph a JSON LD in a way. So we can be very, we are free to create whatever markup we want, right? And then as long as we encapsulate it into JSON LD or RDF, we can, send it to the function that creates the entity for us. Thanks, Jenny. So Here, we also have some custom attributes. This is another features that we might want to highlight. We can create a knowledge graph that it's public for Google to crawl with some public data that can be encoded into schema. But we can also encode into a graph private property. For example, I could take data from Ray tool about the keywords that are ranking for these pages, and I could keep it into the graph as private entities. And so I can create my own namespace that is different from schema and reuse this information within the graph without making it public for Google to crawl it. We realized as we progress that, building a graph, it's really a way of conceptualizing how we see the world and what information we want to have available to create, our own workflows. So this is the function for creating the markup for the PLP page. As you can see, it's very basic. We're using a collection page, and then we're providing, the entity URI, the ID for these entities that is generated using the entity URI function that I have over here. And here the entity URI basically takes the URL, and then, based on the type of page, we'll add offer or we'll add product. And a nice interesting detail is that, of course, when we add, for example, the price, well, the price is another entity in schema because it's a graph. So the price is contained into the offer that it's included into the product. So I have a product graph, and then the product graph links an offer graph that includes the price. So let's see how this works, right? So we can run the show again, and interesting enough, of course, with Advert tool, I can store the crawl data in a file, okay? And so as I progress, as I recrawl, this file will get bigger. Even if I'm just scrolling 10 pages, the file will store the previous scrolls, and so it will be more than 10 pages by now. And what is happening here is that I'm crawling the website. I am reading the crawl data in Advert tools. I am adding, the analysis if it's a PLP or a PDP, and I'm extracting the attributes that I want to use for building the knowledge graph. Then I'm cleaning up the knowledge graph, so I'm starting from scratch. I could prevent this from happening. I could just add more entities, but to make it clean, I wanted to clean it up. But this is definitely not needed. And then I'm starting to build the knowledge graph. And in order to build the knowledge graph, I create entities for every page. And here we can quickly see, what is going on. And, of course, some pages are skipped because if it's not a product and if it's not a category, I don't want to build, an entity into the graph, which we might. But in this very simple implementation, we don't want to. Now, let's see how, as soon as the process is over, and of course, we will have now a few entity because we add in the crawl, previous crawls of other pages. Let's see how we can, start interacting with this data. So the first thing that we can do once we have created our knowledge graph, it's to start query the data using GraphQL. So as soon as I have created my knowledge graph, I can consume the data from the GraphQL endpoint. Now, I do this with a very simple GraphQL query. Here, I'm looking at entities of type product. So I'm not looking at the PLPs. I'm just looking at the PDPs. And I'm asking the graph to give me the entity URI for these products, and then the corresponding category, and then the name of the product, the description of the product, and the URL of the product. And so I'm using the client for performing this GraphQL query and getting, the output out in the log. So let's wait still a few minutes for the graph to be created. Now we have the graph, and now we can, trigger the request. Once again, when I trigger the request, the client will always ask me the API key of WordLift, which again you find here in the dashboard, and then of course the prefix that it's used. So we always use the prefix key, and then the actual key that you take from the dashboard. And then here you can see that as I trigger this query, I'm just getting 10 products, and I can say, okay, now give me 20, And here I'm getting the data out of the GraphQL endpoint. So we build the graph successfully, and the data is coming out. Now, what do we do with this? Because I mean, this is okay. This is a query. It's interesting because I could do several things already, but let's start inject structured data. Let's say that I want to automate structured data. Let's say that I don't have structured data on my website. Can we automate structured data on scale? So we crawl the website. Now we build the knowledge graph. How can we bring the structured data on every page? So we have a data API. Now this is used on very large websites, and we take millions of calls every hour, because they're every time that you open a page of a product that has a WordLift graph behind, this API most probably is invoked. What happens is that we send the URL of the page, and the data API will get the data from the knowledge graph and build for me the structured data that can be added back to the page. We have a JavaScript library that can be added on the head of the page in order for you to benefit from the structured data. And this is the beauty, because I can create structured data in whatever format, from whatever data points I have into the graph, and then inject it back into the HTML web pages. Let's see how it works. So here I have a very simple function that creates a JSON LD from the URL. So here I have a page, fictitious URL of my e-commerce website, and now automatically the graph is giving me the JSON LD for the product, including the offer, the description, and whatever attributes we have in the graph. So as you can see here, we can scale the structured data. We can change the structured data. We can kind of merge the existing structured data that you have with whatever structured data that we are adding into the graph. But what else can we do with data in a knowledge graph? So can we build a neural search? Can we build semantic search? Can we create a system to recommend products, or a system to build links, for example, comparing similar pages, suggesting different internal links? We sure can. So here I've built a very simple function that will take the configuration, so the key, and a URL. Okay, that's all it takes. Because we have created embeddings into the knowledge graph, now that the knowledge graph has a notion of what is similar to what, and has this notion at two different levels. He has this notion because the pages are connected within the graph, so there are triples that say this page belongs to the bags category, this other page belongs also to the bags category. But then there are the embeddings. They're saying, well, these pages are kind of similar, right? They have the similar text. So there is a semantic similarity that is automatically calculated when we build the graph. And now we can exploit it. Now we can say, okay, find me the top K 5 URLs for, let's say, this page over here. And then let's see if it works. Maybe not, maybe doesn't. Apparently it's not working, but well, it will work. But so here, basically, we should get a list of similar pages that are coming from the knowledge graph. Now, might be that the embeddings haven't been yet created, so we will get back here and try to check these in a few minutes. Let's move on. Let's try to see what else can we do with this graph. Now, just to wrap it up on how do we create internal links, for example, or how do we create a similar product recommendation? We have a knowledge graph, and then we have the vector search that is embedded into the platform. And then we can use a language model for generating the embeddings out of specific attributes of the graph. And then we can use these for creating, for recommending links, for creating similar products feeds. But we can also add filters. So we can say, for example, find me the most similar pages provided that the pages belong to the same category, or finding similar pages with products that don't go above 100 pounds. So we can combine the vectors with, whatever condition that the graph allow us. So if I have, for example, a category, I can use the category and say, okay, just give me similar pages within this category. That is the same category of the source product. So now here, we are now using Llama Index. Now, Llama Index is an AI framework that you can use for building AI assistant. And what we're doing here, it's using the knowledge graph as a vector store for Llama Index. So the beauty of it is that we're going to use Nomic. Nomic is an embedding, so it's a technology that will convert a text like AO, SEO into numbers, into vectors. Now, this has been done already for the product automatically by WordLift. But when a user makes a query and converse or ask a question to the chatbot, we will need to convert the question into embeddings and send it back to the vector stores in order to get the response. So here we are, testing the embeddings. We are, leveraging on Nomic. In order to make this line of code work, you will need to get a Nomic key from the Nomic website. It's free, and I encourage you to use it. It's open source. It's a great project, and it scales to different sizes. Here I have now the embeddings, and I'm using OpenAI as a language system. Okay, so I have a language model in this case from OpenAI that will provide me the response. So the components for these flow are these. Basically, I have the user making the query. The query that the user makes is embedded using Nomic. Nomic embedding are used on the vector store built with the knowledge graph. And then we create a query engine that is using OpenAI as a language model to provide a response back to the user. So every time that the user makes a question, we go back to the knowledge graph. We look at semantic data. We look at the data in the knowledge graph to build the context for the language model to answer to the question. So here I am, for example, asking, to get a similar product to the facial poof. This is, I don't know why I came up with this product. And then we also ask the URL. And the assistant, by querying the data in the knowledge graph, it's providing me the response. And of course, I can do this interactively, and I can say, okay, find me the top selling products for the winter. So here, the system is kind of converting the query into embeddings and then going back to the graph and finding, the best solution for, these specific questions. And this is all I have for you today.
Wonderful. Thank you very much. So quick points before we move to Ray. So all of these functions that you've created, they are independent functions, right? So I can create a knowledge graph, I can analyze a URL, I can do this, do that, and users don't need to know the details of this function. They can just run the notebook and say, okay, I just want to select these parts of the workflow, because there's a lot of stuff to go through.
There are a lot of ideas here. So you can build internal links with these. You can build your own AI chatbot. You can use it for generating content because you are effectively building with Llama a retrieval augmented generation system that uses the knowledge graph. So there is a lot of different use cases. Moreover, other use cases are enabled by using the platform, because then we have Agent WordLift that it's also relying on the graph. So there are different use cases.
Great. So this notebook is kind of like a library that I can choose from. I want to do this, 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 or my own sequence of tasks. And beautiful. That's great. Thank you very much.
You've been waiting for this, Elias, for months. I've been promising,
of course,
this
all the time.
But because we
always
were
looking forward to what you're doing.
We were kind of packaging the client library together with my partner and CTO, David, who you know, and we've been really working last minute to kind of showcase the different options that you can now have with
Very
knowledge
nice.
graph.
Like, it's huge, lots of flexibility, and I need to dig into this much deeper, and then we'll leave some room for the guests to ask questions. So wonderful. Thank you very much. Appreciate all the effort. So Ray, you want to share your screen?
Sure. Let me go ahead and do that. All right. I'm going to switch over to my slides here. If you can't see anything, I won't be looking at the camera here for a minute. So if you need to get my attention, just shout.
I can see them fine.
Good. All right. So really happy to be here. I first came across Elias's Advert Tools about 2 years ago, and when I saw it, I just instantly fell in love with it, and have been talking with Elias now for at least a year, and we've been kind of collaborating on different things. And I've known about WordLift for about 2 or 3 years as well, and have always wanted to learn more, and have been very impressed from what I've seen so far. So really happy to be here today. I think that there is a lot of opportunity for these types of tools, whether they're open source or different cloud platforms, to work together more, especially when you start talking about the interplay between SERP analytics and entities and integrating crawl data. And there's just a lot of custom projects that we find ourselves doing when we're helping our clients meet some sort of goal. And so being able to talk to people that actually building these tools is it's a privilege. So I'm going to walk through a couple of things in the slides that just explain our philosophy when it comes to SERP analytics. Probably our company is new to most of the people here on the call, so I'll just explain briefly what we do. Is we focus on large scale SERP analytics. We work with companies that are doing a lot of programmatic SEO, e-commerce companies, job search, real estate, travel, that sort of thing. And then we also work with a bunch of agencies as well. And so the challenge that we see with pretty much everybody that we're working with right now is that obviously the modern SERP is a very complicated thing to deal with. And depending on which industry you're in, you've got your own special set of SERP features that you pay attention to. And as SEOs, we're all very well aware of what the impact these SERP features are going to have visually on searchers. But a lot of times there's a big challenge to explain that to people who aren't living and breathing SEO every day. And so when we talk about SERP analytic workflows, we really try to help people understand the audience and customize the way the data and the insights are being presented as much as possible to them. And by far, the biggest conversation that is happening pretty much everywhere right now is, I love Search Console. It's a great tool, but one of the things that I think it's missing is this gap between, you've got your average position on the organic rankings that has nothing to do really with what that looks like visually to a user. You've got impressions and then clicks and CTR, and there's this big gap and an increasingly large gap between impressions and clicks, which obviously has an impact on CTR. And there's not really a good way to explain what's happening there. And so I think a lot of what people are trying to dive into SERP analytics deeper now is to try to understand that exact story. And again, from the perspective of everyone here on the call, we're all in SEO and we live and breathe this stuff, so it makes sense. But we kind of intuitively understand that real estate on the page, which is usually measured by like pixels and visual features, SERP features, that's going to equal the attention of the searcher. And so helping people to quantify that is a big challenge when it comes to analytics and workflows. And so we've got some ideas on how that can help people depending on the type of team you're on and the type of users that you have to support. But more and more what we're really seeing is that we're way beyond this era of just measuring your ranking and calling it a day. There's just so many things that happen on the SERPs. We in the analytics world, we focus a lot on analytics that happen after the user clicks. So you've got GA4, other tools that are out there that are really good at measuring on-site behavior, but the SERPs are a very rich source of what we call pre-click analytics, where there's a lot of things that are going to influence user behavior, searcher behavior, before they even click onto your site. And then obviously with 0-click search results, a lot of times they won't even click onto your site. And so really understanding the entire picture of that and how that affects your business or your clients is a big deal. And so this is something that we're increasingly hearing people talk about, and I don't think we coined this term, but it's basically holistic SERP monitoring is really the way things are moving. So the big discussion in addition to CTR right now, of course, is what the impact is on AI overviews, and this is having that same impact on overall visibility with regards to how much screen real estate is being taken up by the AI overviews. And that is, there's always all these questions around how much this is actually happening. And so, you know, we see it's all over the map right now, but if for normal logged in Gmail users, it's not, the impact isn't quite as large as people thought it was going to be, but we do think it's going to continue to move in this direction. And we think that over time that the SERP is going to become more and more like a little app per SERP, basically. So there's going to be a lot more interaction that happens there. And so helping people measure that and understand exactly what Google is doing there is going to have an impact on people's ability to forecast and plan traffic for their own websites. So what we're trying to do when we look at SERP analytics is we try to move from just the traditional rank tracking. It still needs to be done. You can't really get away from it, but there's a lot more that happens on top of that. So we've identified 4 main levels of SERP analytics that we focus on when we think about this stuff. And so you've got your rank tracking, you've got your share of voice, which is basically looking at the visual impact of the SERP features and making traffic predictions based on that. And that involves looking at, again, the pixel impact, the position of each one of those SERP features, how much overall share of voice those are taking up for the user. And then from the perspective of the user, what does that visual rank look like? So we may think in terms of you rank number 1 on organic search, but from the user perspective, you may be 4 or 5 positions down on the SERP. And so from the user perspective, you're ranking like number 4 or 5. So it's really important to understand what that means in terms of your traffic and how your brand is perceived. And then the last level is kind of what I was talking about before, which is this complete shape of the SERP and understanding what that looks like in its full form. So one of the easiest ways that we've seen people measure what this impact looks like is just kind of bringing more data into context with the Search Console that you can get, Search Console data you can get. So in addition to your impressions and clicks and overall CTR, you can also start to bring in some simple measurements like what is your overall pixel depth for your site, maybe for your competitors, and use that to basically correlate what you would expect. And so a lot of times what we'll see, I'm going to show you a couple of sites here in a few minutes where we talk about this, but you know, when you have all of that data in one place, it becomes a lot easier to explain to people why, even though they're ranking very well, or maybe their rankings haven't changed much at all, but their traffic numbers are declining quite a bit. You know, again, we may understand it intuitively as SEOs, but explaining that to people who aren't in this world becomes a challenge without these sorts of visualizations and explanations. So that's a pretty big one. And I've got it, like I said, I've got a couple of sites we're going to look at here in a few minutes that'll talk more about this. But when we think about workflows for the analytics data, and I really started thinking about this when we started working with Elias on his class, which if you haven't taken it, I know not everyone is in the class this time, but I strongly recommend it whenever we hire new people. We, especially our clients facing customer, client success reps, we have them go through Elias's class because I think more and more things are moving away from the traditional Excel spreadsheet model. It's always going to be a part of what we see out there, but more and more, I really think that these tools, like Python and SQL-based tools, just offer a lot of advantages that you don't really get with traditional kind of like data sharing tools. So I've put together this 2 kind of axis chart that basically walks through how we look at the types of workflows that you would want to think about when you're looking at SERPs. And I guess the x-axis where you have the exploratory and the operational, axis. What that means, I come from an engineering background, and so everything is, you have to QA everything. And so in the QA world, it's basically you have exploratory QA and regression QA. And so exploratory QA is basically going through and trying to break things, and regression QA is basically you found things that you broke in the past, and then you build a like a test suite of things that you want to make sure don't break again going forward. And so while it's not a direct correlation to SERPs in SEO, there are some good analogies that can be drawn there, because on the exploratory side, what you really should be doing is keeping up to speed with what is happening in the way the SERPs are changing every day, and also understanding what that looks like in terms of how it's impacting your traffic and potentially impacting competitors, if you've got good data on that as well. And then on the operational side is, once you've had a chance to understand the new insights that you should be getting, or you found something interesting on the exploratory side, then it becomes a question of how do you operationalize that if it matters for your team going forward. And that's where you start to get into things like, okay, your daily SERP monitoring, do you need to set up new alerts around that? Are there new integrations that need to happen? Or do you need to build new dashboards? Are there new things that you need to make your management team aware of for something? So these two axes are really they're more of a spectrum in each direction. So a lot of times we'll see, again, things happen in terms of new discovery on the exploratory side, but if there's something that's interesting, you should move that over to the operational side. And then there's, from the kind of like user perspective, the y-axis we're looking at, is it something that is going to be an individual looking at it or a team? And again, a lot of the times you'll see people start as individuals, whether it's a developer or an SEO analyst, to going in there, and they're trying to just find some basic data to answer their questions. And then they can decide after that if they want to share that with their team. And so these different types of workflows, we support a lot of these. And what I'm really excited about with this course that Elias is doing is he's helping people to understand the way that you would use some common data science tools, like, whether it's Jupyter or Google Colab, potentially, working with different database tools. We work with BigQuery a lot, so I'll talk about that. But these are all things that can really help you move faster in your analysis. And then once you've done that, the nice thing about these tools that we're going to be talking about today is they facilitate team sharing a lot more easily, in a way that you can repeat the observations that you had. So this is one of the best things about the data science notebooks in particular, is just like an old lab journal, it kind of walks you through the steps of you exploring that data, versus, if you're just going to pass off a spreadsheet to somebody, it doesn't always tell the full story, and it doesn't walk through all the steps to repeat that analysis. And so that's one of the huge advantages to this process. So we see that even though it's a very, kind of simple graph here, there's a lot here that can really be discussed. And I think we'll be doing a lot more of that too. So as one example, I'm sending some screenshots here just to, I think it's probably pretty clear, but just some examples of the way these workflows would work. So this would be an example of like an operational workflow where you've got your daily SERP monitoring. Everyone uses, some version of this. Doesn't really matter what tool you use for this, but you're basically trying to stay on top of your rankings. And then an exploratory tool would be something that we call SERP Rewind, but it's basically just archiving your SERPs on a daily basis, and making sure that you understand how those SERPs are changing over time. So you can go back in time, we say rewind it, and you can compare, things. A lot of times that can be really useful if you see a big drop in traffic or a big change, or you think that there's some new SERP feature that has impacted your traffic. You can go in there and see exactly what that looked like for all the different keywords. So it's good to be able to combine these things in an environment that you're comfortable using. And so for this course, what we've done, I've done something similar. We chose to use a Jupyter notebook, but I like the Colab thing that Andrea chose as well. So we may do something there too. But this is the first time we've put something like this together for our audience. Most of our customers, when they use our API, it's usually for integrations into their existing reporting platforms. So they're pulling it into BI tools and so forth. So it's been a lot more of that operational type of data integration. But I think that it's nice to have this sort of interactive capability as well. And so we've got a repository. So anyone that's in the class, we're going to give them access to this, and they'll be able to copy down the Jupyter notebook for themselves and run it. And for anyone who is in the class and has questions, you have an account with us, so you can reach out to me, and I'm happy to walk you through these specific examples, or walk through some potential scenarios that you'd like to model out a little bit further. So I'm going to switch over here away from the slides in just a minute to walk through this. So we'll come back to that. I just want to mention one other thing that is really good for this sort of analysis is I don't know how many people are using BigQuery right now, but that's another tool that we found to be really useful for storing data. And whatever schema you choose, think about taking all the detailed data of that and pushing that into BigQuery. And it gives you a lot of advantages. You can actually even pull BigQuery, the results of BigQuery requests into notebooks as well via Python. You can load that into a data frame and everything. So there's a lot of really cool things that you can do with getting results from your main operational data set, but then use that in an exploratory manner and vice versa. And so they play off of each other really well. And one of the things that we've done is we just pre-built a bunch of queries for people who are using this. And you can see this list of there's so many different use cases that once you get a centralized repository of data, you can go through this entire list of things to really start helping your team understand what is happening with the SERPs in your particular market. So, there's a lot that we can do with this. I'm going to switch over to the Jupyter Notebook now and talk about just walking through some of the examples that we have pre-built there. And then I'll come back to some of these things where we can talk about what you would potentially do beyond this. But the notebook itself is very simple. When you get access, you'll basically go in. We've got two API versions. We've got our 3.12 endpoint. And this is kind of our standard one where if you just need your day-to-day rankings, it's great. You come in here, you set up your API key, and it has all the things built in for you to manage. A lot of customers, we've been managing multiple sites, for example. And so being able to get all that information, add new sites, you can pretty easily do that. And then if you just need a simple view of your rankings, this is a great endpoint to use, and you'll get everything on a daily basis. The biggest challenge with working with these types of data sets in a notebook is if you're running a large site, for example, it's pretty common to see sites that are trying to monitor 10,000, 20,000, sometimes hundreds of thousands of keywords. And so loading all of those as a data frame into a notebook like this can be a little bit cumbersome. And so you can do things to limit the size of that data. And you can see we run list.co.uk as a demo site. We're going to look at that here in a minute quite a bit. So you can, anyone who needs access to that site for the class purposes, we'll give them access to that so they can get some data that's been running for a long time. So you'll be able to go in there and get a lot of cool information. You can query about what competitors are showing up there. And then we have the new V5 API, which is our newest API. The entire API itself is still in beta, but this one endpoint that we use, basically, you'll get probably 80% of what you would need. And what you're going to be able to do with this is you're going to get into a lot more of the visual analytics that we were talking about. So looking at the data set that we have here, we've got the ranking data. You'll be able to get pixel data, SERP feature information, all of the Search Console data. If it happens to be connected, you want to pull that in here as well. So it becomes a pretty large data frame. And so there's a lot of, the way that the thing is structured is to support a couple of different use cases. And so we go through a flattening process here. I had the bright idea when Andrea was talking to try to make some live edits, and I messed up this one. So we'll get that working for you guys. But you basically flatten that, and you've got a data frame that you can work with. And I've just put in a couple of examples here around, automatically clustering the data, a good production clustering data pipeline, which we support for clients would be much more sophisticated than this, but it's just to help people understand the idea of using clusters here. So it's a good way to start working with the data. And this, like I said, this is kind of a newer area for us as well. So there's going to be a lot more we're going to be adding to this, and we're going to be doing some things with pulling in BigQuery and merging some of these data sets to AdverTools crawl data as well. and potentially WordLift. WordLift, we still need to learn a little bit more about it, but it's a very powerful platform. So I think there's a lot of, like I said at the beginning, some good opportunities to really start combining the data sets from these different platforms. So that's a quick walkthrough on the notebook. Again, as you're going through this, if you're in the class, feel free to hit me up, and we can schedule a call to just make sure you're all sorted out. And then if anyone is using BigQuery for any of this, I think it would be worth talking about this too, because I think there are really good opportunities to query BigQuery with the API and then pulling that into a data frame within the notebook as well. I think that's kind of a missed opportunity for a lot of teams when they're doing these sorts of exploratory workflows. And so that is the main thing. So in terms of like what you can do beyond that point, one potential axis that I would add to this workflow kind of grid that I spoke about a minute ago would be deployability. I think one of the challenges for pretty much all of us right now in this kind of like technical space where we're not full-on developers is being able to actually deploy that beyond just running simple notebooks. And so that gets into infrastructure and so forth. It's kind of a whole other conversation, but I think it's a big topic. I don't want to go too long on that one. So anyway, I'd love to hear from everyone. Feel free to get in touch if you have any questions or just want to chat more. I should have put my email address here, but it's just ray@demandsphere.com. And I know Elias will have all that as part of the class materials as well.
Great. So many things to dig into. So if anyone has any question or remark or thought, just please type it in, and we'll try to answer as best we can. I have a bunch of questions. So until someone asks a question, let me start with a thought that I have to Andrea. So my assumption is that when we work with AI is by definition working with unstructured data and unstructured questions. Like if it's really structured, like numbers and sorting, we just use traditional software.
Correct.
The problems as structured as possible, and one of these things is creating knowledge graphs and giving more structure so we can ask easier questions to the AI and make it less likely that it makes mistakes. What do you think about this? Do you agree on this approach, or what do you think?
Well, I mean, recently there's been a lot of hype in the context of knowledge graph because of the opportunity that a knowledge graph represents in providing context to a language model. Mike Dillinger, who is the guy behind knowledge graph at LinkedIn, used a term that I really love, that is knowledge graph is a jet fuel for a language model. And that's exactly the case, because even if we look at a simple question like the one that we were trying before, and we try to say, hey, what are the products that cost less than £100 that will fit me well, with this skirt? There are some elements of these questions that can be effectively translated into vectors, and therefore a language model could grasp some of the answer. But the reality is that as soon as you want to find, for example, the product that costs less than £100, a mere vector representation will not work well. And so by providing the context within the relationship of a graph and the discrete attributes, let's say, of a product and its price, we can actually provide an accurate response to that. So really our work, it's around these. It's around moving the unstructured into a graph, creating relationship in a model. Because the other point is that, for example, when I was looking at Ray's data, I immediately thought, okay, what data I want to have in the graph? Because again, this is structure and it fits well with some of the workflows that we might envision. For example, I might decide to create internal links because the pages are similar and therefore I can use the embeddings, or I might create the links for the pages because they are similar and they belong to the same category of products. But then I might also decide that, for example, based on the crawlability of the page, I might boost some pages over others when re-ranking, the list of similar pages. So the more data we can kind of bring into action, the more we can create accurate, workflows. So we want to get the data and we want to bring it into the graph, because that's kind of the way we use for interacting with AI. And in some cases, we don't need a language model. For example, if I have to create a cluster, I can just use an algorithm like k-means, and I can use the embeddings that now are into the graph. And actually, if Valentina brings me back the screen, I have the search that now it's been, the embeddings have been created, and so now we can actually trigger, a similarity search and say, okay, find me the top 5 or the top 10 pages that are similar to these, and then the knowledge graph will immediately give me the response of the similar pages. And here I'm not using, of course, any particular condition, but I could get very deep and say, okay, give me the similar pages and then only order them by the one that was the least crawled by Google using race data. And
we have more confidence with this because we've structured more data. Like we're not, you can ask an LLM which is the most similar page to this one, and it could give you a very vague thing. But here, now that we've structured things and we said this is this type of entity belongs to this is the relationship with that, then like we're asking it to do something that for humans is a bit structured and tedious, but it would really make our lives much more efficient when we have a large language model do this for like 10,000 or 20,000 pages. And we have more confidence.
The game for confidence and trustworthiness, it's really about then the data model. Like, what data do I want to have into the graph in order to take the decision that will, trigger the automations? And of course, we want to take the least amount of data, but we also want to trust the data, right? So we want to get data that we can trust. And for example, one question I have for Ray is like, how are you processing the AI overview? I mean, what level of confidence do you have of, AI overview, which is, by design a feature that it's, personalized per user?
Right. The personalization you can't do much about, really. It's the big challenge. Well, that's one of the challenges is personalization. The other challenge is simply getting the data in the first place, because they're only releasing it to people who are logged in right now. And so in order to get it, we had to build our own cluster of Gmail accounts. So we have a few thousand right now, and we'll probably end up having tens of thousands, as we continue to scale out the operations of that. They'll probably end up just opening it up for everybody as soon as we do that. So we won't need those Gmail accounts anymore. But in the meantime, it's a big priority. But that's kind of how we do it. Personalization, the only way to potentially personalize it would be is if we like built in behavior history for each one of those Gmail users, but I'm not sure how much value there would be for that. It might be worth testing.
Based on the analysis that you've done so far on these accounts, I mean, is there a kind of a common trait of the AI overview coming out of a given query, or there is a lot of volatility because the users are getting different responses every time? I mean, we're talking about stochastic systems that in general will not be too reliable.
So what we've noticed is there's been a big drop off from the types of queries like measured by intent that used to be there. Just when they released this in May, we're seeing a lot more initially on like a lot more commercial terms than we would have before. And so now it's probably maybe 60-70% of the appearances are for informational type queries, which makes sense, if you're asking a question about something. So the commercial one is going to be interesting. When we started testing this about a year ago, when it was only in Search Labs, we would see them everywhere, and they were like massive expand. I'm sure you saw it as well. And so even for like commercial things, like I was ready to buy something, a laptop, you would see massive result sets. So we don't really see anything like that nearly as much. So I don't know if that answers your question.
Why do you think that is? I'm just curious. Is it not working or?
Well, there's all these factors. There's some kind of like pushback in the industry right now. I think their ad revenue is the main thing they care about from the business impact. So anything commercially related, they're going to probably tread lightly there because they want to make sure. For example, like one of the things that we do see when there are appearances on the commercial keywords is that a lot of times the ad units are going to show up above the AI overviews. So the priorities are pretty clear there. Where when it's not like a commercial term, you're going to see that at the top. More like you'd expect it to see.
And there's much more risk here because Google has always been about, they don't give you content. They tell you, we think there's the answer to your query, but now they're like getting into, here's the answer.
Right.
And this gets you into so much, I don't know, trouble or risky things that, you didn't even know about because these are generated by AI.
They have a provisional patent application that's out there. I almost included it in my deck today, but I can include it and send it later. But we did a little bit of review on that in our conference last week in Tokyo. But the long and short of it is they're playing with that quite a bit, because the big deal is, everyone, I think people kind of think or assume that the overviews are generated as some sort of summary of the results, but at least based on this information, that's not, and I don't think that approach would really scale. Yeah, right. There's no way to make that work. So they're generating it out of their own LLMs and then using the ranking URLs to potentially verify that information, which probably bumps right up into the type of problems that you're talking about, Andrea, where a knowledge graph is going to be a much richer way to validate things within context versus just like, some URL happened to say something. So it's definitely worth reading through that document though.
Cool. I like the grid you made where the data science part gets into the exploratory part, where you don't have to go to developers and say, I want this, and then discover 6 months later, oh, sorry, I meant that.
Exactly.
And,
So
it looks familiar. It sounds familiar. Huh? So I think, this is a very important thing, because if I'm going to be using that dashboard or that application, and I have some data science skills there, I think it's going to enable me to specify much more clearly what exactly I want. And I can test out with a few notebooks here and there for a few months and say, okay, this is exactly what I want. This is the data that I want, and this is the format. These are the charts. Please build it for me so we can build on top of this.
Exactly. Yeah. You can convert it over just a normal Python script pretty easily too.
Yeah. So now we have the WordLift API Python library as well to play with.
That's super cool.
And I mean, like both of the data that both of you work with is very interesting to see what can be.
We need to get a big notebook together that pulls it all in one place. And
already starting to think about that. So maybe we'll have another episode where that bigger notebook is.
I think it's interesting because also, one positive aspect of the AI becoming mainstream is that really everyone has access to programmatic tools, and then it really becomes important to move from exploratory to operational with some good ideas, right? And at the end of the day, the tooling is there. We can experiment. We can do it at scale, right? We can experiment on a small site, but then immediately the tooling that we have available allow us to scale to hundreds, thousands of pages. But it's all about the ideas, where is the idea coming from? What is the advantage that we want to build? I mean, it's about increasing the trustworthiness of the content on the page. It's about, trying to see if by building new content, we can get into this AI overview, and then maybe we can measure if that it's working or not. I mean, what is the idea? And that's I think the beauty of SEO is that it's a world of ideas. It's a world of intuition. And we just have now better tools, but it remains that there are some good intuition and some bad intuitions.
And we should test it before taking it to production.
Exactly. Yeah, you can test it much faster.
That's great.
Wonderful. Okay, so I think we've left everyone with a lot of stuff to think about, to explore, to experiment with, and each other as well. So if nobody has any other questions, I think we can wrap this up. I really appreciate your support on this, your help, all the work that you've given, the credits, and the notebooks and the work here. And I'm sure we'll find many ways to collaborate on this and work more. And we'll see how that goes.
Looking forward to it. Thanks very much.
Okay. Thank you very much.
Thank you.
See you next time. Bye-bye, guys.
All right.
Bye.
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 Thanks.